Pick up your phone. You just defeated the gravitational pull of an entire planet. 6 trillion kilograms of rock pulling on that phone, and your arm just won. That shouldn't be possible. Unless gravity is hiding something from us. Gravity is the weakest force in the universe, and not by a little. Electromagnetism is 10 to the 36th power times stronger. That's a 1 followed by 36 zeros. That number is so large it stops meaning anything. Here's what it looks like in the real world. Take a fridge magnet, stick it on your fridge. That tiny magnet, maybe an inch wide, is overpowering Earth's gravity. The electromagnetic force in that cheap magnet is beating a planet. In physics, the fundamental forces should be comparable. They emerge from the same underlying framework. It's like having 4 siblings, where 3 are professional athletes and 1 is a bacterium. You'd ask questions. This is called the hierarchy problem. And physicists have been asking questions for decades. But wait, black holes have incredibly strong gravity, right? They swallow light, they warp space-time. Not quite. Black holes don't have stronger gravity, they have more concentrated gravity. Gravity depends on 2 things: mass and how close you are to that mass. If you compressed Earth into a marble-sized black hole and stood where the surface used to be, you'd feel the exact same gravitational pull. Same mass, same distance, identical gravity. Black holes only get extreme when you move closer than the original surface would have allowed. Now you're inches from all that mass instead of 4,000 miles. But here's what should disturb you. Even inside a black hole, electromagnetic forces are still stronger. The bonds holding atoms together resist until the very last moment. Gravity needs the most extreme object in the known universe, matter compressed beyond all physical limits, to finally overpower what a fridge magnet does casually. The weakness isn't an edge case. It's baked into the force itself. So where's the missing gravity? In 1998, 3 physicists proposed an answer that changed how we think about the universe. Arkani-Hamed, Dimopoulos, and Dvali suggested, gravity isn't weak, it's just not all here. Imagine you're an ant living on a sheet of paper. Your entire universe is that 2D surface. You can move forward, backward, left, right. Up doesn't exist for you. Now imagine someone pressing their finger down on the paper from above. From a dimension you can't perceive. You'd feel something. Pressure. A force appearing from nowhere. But it would seem weak and diffuse, because you're only experiencing the tiny cross-section where the 3D finger intersects your 2D world. That might be gravity. If our universe is a 3D membrane floating in higher dimensional space, and gravity is the only force that isn't stuck to our brain, then what we feel as gravity is just the fraction that bleeds through. The full-strength gravity could be out there, in the bulk, in dimensions we can't access. We're not surrounded by another dimension, we're soaking in it. This isn't just philosophy. In 1999, Randall and Sundrum showed mathematically how a warped extra dimension could dilute gravity naturally without any fine-tuning. The Large Hadron Collider has searched for evidence of extra dimensions by looking for gravitons, the hypothetical particles that carry gravity, leaking into other dimensions. So far, nothing conclusive. But the absence of evidence isn't evidence of absence, especially when the math keeps demanding something we haven't found yet. String theory requires 10 or 11 dimensions to work, not as a preference, as a mathematical necessity. Every time you lift your phone, you're participating in the hierarchy problem. Every time a fridge magnet stays stuck, you're watching gravity lose. Either there's a fine-tuning of cosmic proportions that nobody can explain, or most of gravity is somewhere we can't see. We might be feeling the echo of something we'll never directly touch, the shadow of a force that's stronger than we'll ever know. So what else is leaking through from dimensions we can't perceive?